Hola, hola. Dame un segundito. Hola, 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 hola. Estimada concurrencia, junto con saludarles y darles la cordial bienvenida, les invito por favor, antes de iniciar la ceremonia, silenciar los celulares. Autoridades presentes, distinguidas y distinguidos expositores nacionales e internacionales que nos acompañan, invitados especiales, señoras y señores, tengan todos ustedes muy buenos días. La Universidad de Tarapacá les da la bienvenida a todos los presentes al taller de expertos sobre fuente y peligrosidad de tsunami en el sur del Perú y norte de Chile. Actividad de carácter internacional financiada, por la UNESCO y que tiene por objetivo determinar posibles escenarios de terremotos y tsunamis que se podrían dar en la región fronteriza. Estimada concurrencia, para referirse a la importancia de esta actividad para la universidad, se dirige a los presentes la señora Bernardina Cisterna Arapio, directora general de vinculación con el medio de la Universidad de Tarapacá. Directora.
Ok, gracias. Bien. Señores seremis, señor gobernador marítimo, autoridades regionales y universitarias, señores expertos, invitados especiales, señoras y señores. En primer término, reciban nuestra cordial bienvenida a nombre de nuestro rector, doctor Emilio Rodríguez Ponce, y también de toda nuestra universidad. Hoy centraremos el interés en los terremotos y tsunamis, que son fenómenos en que las comunidades de la zona norte de Chile y sur del Perú han convivido durante siglos. En ambos países se han desarrollado capacidades para adaptarse y prepararse en muchos ámbitos. La colaboración y cooperación entre los científicos, gobiernos y poblaciones locales es crucial para anticipar, mitigar y responder de buena forma, de buena manera a estos eventos naturales. Muchas veces estos eventos han revelado la fragilidad de la relación entre el ser humano y el medio ambiente. La ocupación humana de zonas costeras y la explotación desmedida de recursos naturales pueden aumentar la vulnerabilidad ante los tsunamis y los efectos secundarios de los terremotos. El desarrollo sostenible y la planificación territorial consciente de los riesgos son cruciales para proteger vidas y bienes. Esta reunión de expertos sobre fuentes y peligrosidad de tsunamis en el sur del Perú y norte de Chile, que tal como lo ha dicho aquí nuestro locutor, financiada por UNESCO y organizada en conjunto con la Comisión Oceanográfica Intergubernamental y la Universidad de Tarapacá, ha convocado a connotados expertos en esta zona norte de Chile. Bueno, comprender, modelar, anticipar y prepararse para futuros terremotos y tsunamis es esencial para proteger y concienciar de manera efectiva a las poblaciones en riesgo de esta zona del mundo. Dada la corta distancia de la trinchera a la costa, cualquier tsunami generado en esta región se propagará en decenas de minutos. Por lo tanto, existe una necesidad real de una mayor preparación, concienciación, ya que el tiempo de advertencia puede ser muy corto. Aproximaciones numéricas, novedosas y analíticas para evaluar las fuentes de tsunami y discutir el posible papel de los deslizamientos de tierra en la generación de estos eventos naturales probablemente serán temas que se analizarán, ¿no es cierto?, y discutirán, y será lo que enriquecerá las jornadas. Bueno, esta importancia, ¿no es cierto?, ante estos eventos que normalmente estamos expuestos, es algo que ha convocado a la Facultad de Ciencias, al Departamento de Física y en especial, ¿no es cierto?, a los expertos que trabajan en esta área, de interés para nuestra universidad por el rol que nos corresponde a nosotros en esta región y en esta zona norte del mundo. Bien, finalmente, para dar inicio a esta jornada, solamente agradecer a todos su presencia y especialmente la disposición de los expertos que van a participar contribuyendo al conocimiento sobre estos eventos naturales para así prepararnos mucho mejor y mitigar cualquier impacto que se proceda, ¿no es cierto?, de este tipo de situaciones naturales. Por lo tanto, los invito a compartir esta disposición de trabajo importante. Muchas gracias.
Agradecemos las palabras de la señora Bernardina Cisterna Arapio, directora general de vinculación con el medio de la Universidad de Tarapacá. En el marco de tan significativa ceremonia, hace uso de la palabra el señor Bernardo Aliaga, jefe de la sección Tsunami y Resiliencia de la Comisión Oceanográfica Intergubernamental de la UNESCO, y el contacto se establece desde París, Francia. Bienvenido.
Muchas gracias y buenos días a todos. Como, como lo dijo muy bien la representante de la Universidad de Tarapacá, esta es una reunión que tiene que levanta muchas expectativas en términos de cómo estamos, del grado de conocimiento que tenemos de una zona tan peligrosa para tsunamis y terremotos, como es la zona en la que están ustedes hoy día. La experiencia del sistema del Pacífico es una experiencia que está grandemente basada en el conocimiento de la amenaza. Es uno de los tres básicos pilares de desarrollo del sistema de alerta del Pacífico, que más recientemente se ha denominado también de alerta y mitigación. Y ese es un cambio en el enfoque que es relativamente reciente con respecto a los más de 60 años de existencia del sistema de alerta en la región del Pacífico. Yo quería simplemente agradecer enormemente a los colegas que han colaborado en la organización de esta reunión. Quería agradecer en la persona de Bianca Glass al señor rector de la universidad, a la Universidad de Tarapacá. Quería también agradecer a los colegas que son nuestros puntos focales históricos en Perú y en Chile, de la Dirección de Hidrografía Naval del Perú, de la Armada del Perú, y del Servicio Hidrográfico y Oceanográfico de la Armada de Chile. Tenemos una relación ya bastante dilatada, pero se han introducido en el curso de los últimos años en el sistema nuevos actores y están entonces cada vez más presentes las organizaciones de manejo de catástrofes o de emergencias, como el CENAPRED, como el INDECI, y por supuesto se ha ampliado mucho más el núcleo reducido de científicos y de expertos que compusieron el núcleo inicial del sistema del Pacífico, que se llamaba antes ITSU porque era internacional, era solamente uno. Ahora tenemos ya 4 sistemas y se discute acerca de la expansión hacia otras zonas como la costa oeste de África o la zona del Atlántico Sur. Y también hay voces que se elevan respecto de las amenazas de tsunami en las zonas polares. Entonces, estamos en un periodo de plena expansión del sistema, pero volvemos a nuestras raíces, y volvemos a nuestra raíz esencial, que es discutir y conversar y trabajar con los científicos y los expertos de verdad que están haciendo investigación, que están publicando, y dejarles la oportunidad de discutir libremente y de organizar los conocimientos, compartirlos de diversos ángulos. Hemos invitado historiadores a participar en este tipo de reuniones, paleontólogos, que tienen algunos, creo, en la reunión, arqueólogos. Bueno, como chileno, por supuesto, muy contento de que esto se hubiera podido organizar finalmente allá, desde el 2009, 2008, perdón, cuando hicimos un primer seminario en la ciudad de Concepción, discutiendo acerca del peligro de la zona sur austral, con Marcelo Lagos, que está ahí presente, con en ese tiempo el doctor Cisternas, que era muy conocido por un evento en Valparaíso, que se discutía en la época y se modelaba en la época, y otros distinguidos colegas de la región y del país. De allá hasta hoy se ha caminado un montón y la prueba está en que esta reunión es 50-50, claramente, de expertos chilenos y también expertos peruanos. Y eso es un gran avance en la región, eso está dejando capacidades, está... eh, yo les voy a ser honesto, hace mucho tiempo que no voy a Chile, Perú, Ecuador y Colombia, porque trabajan muy bien solos, casi no nos necesitan. Eh, pero bueno, les deseo una fantástica reunión. Les deseo que lo pasen muy bien, que aprovechen las tardes. Me encantaría estar nadando en la mañana temprano antes de ir a la reunión, pero bueno, así es la vida. Un abrazo para los amigos más cercanos y que lo pasen muy bien. Gracias de nuevo a la Universidad de Trapacá.
Muchísimas gracias. Las palabras del señor Bernardo Aliaga, jefe de la sección de Tsunami Resiliencia de la Comisión Oceanográfica Intergubernamental de la UNESCO, quien se ha comunicado con nosotros desde París, en Francia. Concluimos de esta forma este acto inaugural. Daremos paso entonces a las conversaciones, a cada una de las presentaciones, en otras palabras, a la jornada propiamente tal, que es la jornada de trabajo. Aquellas autoridades que deseen continuar con su agenda, por supuesto, quedan en libre de hacerlo. Muchas gracias y tengan todos ustedes muy buen día, buena jornada.
Sí.
Señoras y señores, rogamos su atención, por favor. El Gobierno de Chile y la Oficina Nacional de Emergencia, a través de un instructivo, les recuerdan a todas las personas que concurran a diferentes lugares abiertos o cerrados, seguir los procedimientos de acuerdo a los planes de emergencia y evacuación de cada recinto. Por lo tanto, ante la eventualidad de un evento natural o de una situación de emergencia, se les indica que el lugar en que nos encontramos se encuentra habilitada con salidas de emergencia debidamente señaladas. Al ocurrir un hecho natural, se les recomienda mantener la calma, proteger su cabeza hasta que disminuya la intensidad del movimiento. Luego, dirigirse hacia las salidas de emergencia para seguir el circuito hacia los jardines y posteriormente, seguir las instrucciones de los brigadistas para dirigirse a las zonas de seguridad. El abandono del campus es a pie. No es posible usar vehículos. Lo más importante ante una situación es mantener la calma y seguir las instrucciones. Por vuestra atención, muchas gracias.
Muy buenos días, señoras y señores. Mi nombre es Luis Gajardo, somos el Departamento Técnico de Audiovisuales de la universidad y estamos acá para atenderlos. En estos momentos tenemos señal libre de Wi-Fi, ¿ya? Se conectan a la sala Ricardo Salas. Los servicios higiénicos están al fondo, saliendo para el pasillo, mano derecha. Y cualquier inquietud o consulta estamos acá para atenderlo. Que tengan una muy buena jornada.
Bueno, pues, ¿esto está encendido? ¿Se me oye todo el mundo? ¿Bien? ¿Me oyen? ¿Me oyen? Sí, está entendido. Bueno, pues seguimos con la agenda que teníamos preparada y vamos a oír otra vez a Bernardo Aliaga. Hemos dejado ya un poco las formalidades de las personas de las autoridades y empezamos ya con lo que es más centrado en el taller. No todavía la parte técnica al 100%, pero nos centramos ya con participantes que se dedican a los tsunamis y a los terremotos y a la alerta y a la prevención. Entonces vamos a oír las primeras palabras de Bernardo Aliaga, que como hemos visto antes llama desde París. Es el director de la sección de tsunamis del IOC, del Intergovernmental Oceanographic Commission. Y Bernardo, si te puedes conectar, te escuchamos.
¿Sí me ven?
Sí, te oímos, te vemos y te oímos.
Ok, perfecto. Voy a sacar solamente el vídeo y voy a intentar compartir mi pantalla. Chile. Y ahora voy a lanzar la presentación, solamente me confirman de que están viendo en pantalla la versión display. ¿Sí?
Sí, lo estamos viendo bien.
Muchas gracias.
Sí, la tenemos en pantalla, Bernardo.
Perfecto. Entonces, voy a hacer una presentación muy breve, me han asignado 15 minutos y de lo que voy a hablar es esencialmente de introducir a algunos de los colegas que están en la sala qué es el sistema de alerta del Pacífico, en qué contexto se inscribe y cuál es entonces el origen de esta reunión de expertos, para dónde vamos, desde dónde venimos. Venimos de hace mucho tiempo atrás, 1952, 1948, el primer observatorio magnético de Honolulu. El 65 se funda un primer grupo de trabajo a raíz de los intercambios esencialmente entre Chile, Japón, en la época Ecuador, la Unión Soviética en la época, y Estados Unidos, en particular por los impactos en Hawái, en Honolulu, en Hilo, del tsunami de 1960, se genera un grupo de especialistas, un grupo de trabajo que se llamó primero un Grupo Internacional de Trabajo sobre los aspectos del sistema de alerta de tsunami en el Pacífico, organizado por los americanos en principio en Honolulu en el 65. Después de esto viene el establecimiento formal del ITSU, del International Aspect of the Tsunami Warning System in the Pacific, in 1965. And then we go to the 1977 establishment of Honolulu Observatory Renamed Pacific Tsunami Warning Center, PTWC, thereafter. Our first master plan is from 1989. And then we have the Indian Ocean tsunami 2004, and in between there is just a small group of experts that met every 2 years, sometimes every 3 years, to discuss about the technical aspect of tsunami warning system and scientific aspect of tsunami warning system. They were calling, for example, for the establishment of an Indian Ocean tsunami warning system. Few years before the tsunami in the Indian Ocean. But that was not successful at the point that the role of the UNESCO and the role of the IOC in the tsunami warning systems was unknown to the population, unknown to the public, unknown to decision makers, essentially. That remained within a relatively small circle of experts and scientists and some practitioners. So in 2005, there was a big blast and a big ask of member states to establish tsunami warning system everywhere, in particular in the Indian Ocean, but also in the Caribbean, the Mediterranean, and the northeastern Atlantic. So there is where there is our origin. How it was established is step by step, and then with a big difference between before and after 2004. Today, this is what it is. It's a very complex ecosystem of intergovernmental groups. As I said, we have 4 Pacifics, Indian Ocean, and Northeastern Mediterranean, and Northeastern Atlantic and Mediterranean, with each of them with a specific center that is dedicated to awareness, public education, and training, which is at the origin only one, the ITIC in Honolulu, but today we have 3 more. One hosted by Indonesia in Jakarta by the Bureau of Meteorological and Geophysical aspects in Indonesia, in Jakarta. And then in Barbados, in Bridgetown, the Caribbean Tsunami Information Center hosted by the Coastal Zone Management Unit in Barbados. So we now have a very mature system, if I may, and we have 13 what we call tsunami service providers. What is the role of UNESCO and IOC in all of this? Is helping to put together the work of experts, the work of practitioners to develop standards and publish those standards that become the norm. Now, how is that done? This is part of just one of the ICGs, the structure of working groups and task team for the past 2-3 years. With Japan, a colleague from a senior expert of the Japanese Meteorological Agency, Yuichi Nishimai, as chair, and then the head of operations of the New Zealand Emergency Management Agency, David Coetzee, and then the head of the Central America Tsunami Advisory Center in INETER in Nicaragua. So just in this slide, and you can see Jorge Matus, that is the chair of the Regional Working Group on the Southeast Pacific. Just in this slide, you can see 20, 30 people that are at the core of the Pacific. But if you count, for example, just the focal points of each of the 48 member states, you get easily to 300, 400 people that compose just the Pacific group. That meets every 2 years. We are meeting in Tonga, 11 to 15 September this year. And all these working groups meet in between, and task teams in between through either in presence or online meetings. But I said this is a mature system, but then the 2011 Tohoku earthquake and tsunami came, then the Palu, Indonesia surprised a little the community, and then the Tonga event was even more surprising. So there are something that need to be just worked out to say that this is a real effective system. And one thing that we have been working on and developing a standard as well is in community preparedness. So we have now a UN Ocean Decade Tsunami Program for the next 7 years until 2030 with specific outcomes and specific targets. One of the outcomes is get tsunami ready or prepare for tsunamis, 100% of communities at risk of tsunamis. This is a huge challenge, and we are working all together towards this end. The UN Ocean Decade Tsunami Program has 4 components that are building in the same company we have been building for years. One of them is risk knowledge, and I just quote from the implementation, the research and implementation plan of the UN Ocean Decade Tsunami Program, that we aim to improve our understanding of the tsunami hazard by expanding our knowledge of past or potential tsunami sources. How we do that? Well, we have been hosting these kind of meetings in 8 places. We started in Haiti in 2013. Then we went to Southern Hispaniola, Dominican Republic, and Haiti. Then there was a specific meeting on the South China Sea region. Another one in Central America. And the next one was in the Lesser Antilles. And the following one was in the border, Ecuador-Colombia, sorry, just before the pandemic in January 2019. And another one that we hosted was the Tonga Kermadec Trench. So this specific meeting has been on the pipeline for at least 3 years. And now we are materializing this one. Probably the next one will be in the New Hebrides, in the continuation of the Tonga Kermadec Trench. So I wanted to just share the general context so you know where you are in terms of who is organizing this, why we are organizing this, and what the outcomes are for. There will be other presentations during the meeting and over the next few days that will be more in detail about these elements. But I wanted just to make sure that we have a common understanding of why, where, how. Thank you. And of course, I'm open to questions.
Muchas gracias, Bernardo. Y como ha dicho Bernardo, tenemos un poco de tiempo quizá para un par de preguntas, si hay alguna para Bernardo. Creo que hay un micrófono por la sala, entonces si alguien tiene una pregunta, que levante la mano y y se le pasa el micrófono.
So thank you, Bernardo, for this nice presentation, for this introduction. I have a question regarding this meeting in particular. What do you expect related to specific products of from this meeting and from this discussion that we are going to have regarding eventually some public policy or social impact? I don't know. What do you expect from this meeting and to get together all of these experts? Thank you very much again for the invitation and for this organization to UNESCO.
Thank you. Let me start by the beginning. And the beginning is closely related to Emil Okal. Is in the room because we were in a plane going to a meeting in Guadeloupe, I believe, and we were discussing about the source of the 1842 northern Haiti tsunami, and there were kind of two very opposed teams of researchers about the potential source. One was more geodetic minded about the origin based on GPS measures. They thought that the origin was the prolongation of the fault that go through the north of Dominican Republic, pass by Santiago, and then go into the sea. And that fault passed 200 kilometers north of Haiti. And then a few more 100 kilometers north, there is the mainly strike slipping fault or junction of the Caribbean and North America plate. And there was another team that was more focused on that explanation, that the origin of that 1842. And they were communicating by papers in journals or in workshops. So the emergency managers, this is 2013, we just had the 2010 earthquake and tsunami in Haiti. There was a tsunami in Haiti in 2010. And they were asking what is the potential of tsunamis in the north of Haiti. And there were many people that was interested on that, and not only the local emergency managers, but UN organizations working in Haiti. So we started from that and organized that meeting in 2013 in Haiti. But I remember that was an interesting discussion. And when I first posed the idea, when I put the idea, some colleagues in the tsunami community, practitioners mainly, told me that it's impossible to get experts to be in agreement. That was not possible, that they will not meet. And that the battle of egos and etc., all of these kind of things, I am very informal here. So was difficult to be surmounted, and there was little experience of getting together colleagues from different expertise to get agreement on sources for tsunami, even for past events, even more for possible potential future events. So, and the meeting was a success. The meeting managed to get the geometry and put together 3 or 4 potential scenarios, not only the ones that were discussed before, but new ones that were also discussed. And then the concept of the meeting itself has evolved over the years in these 8 meetings from a more deterministic only way to a more a mixed approach of probabilistic and stochastic even, and deterministic approach. But the key question that the emergency management community is in need of is more or less simple. What is the potential? What is the magnitude of an earthquake? What is the expectations in terms of tsunami inundation that they should have in a given area, region, etc.? That's an answer that is not always simple to provide. But that's why these meetings are very open. I'm not expecting specifically one kind of answer. Might be many, and maybe just a list of research questions. It all depends on how the meeting evolves. It all depends on the maturity and the status of knowledge, because some meetings cannot be organized because there is no data. There is no new knowledge in some regions that could help to produce this kind of meetings and have results, real results. But in the case of northern Chile, southern Peru, I believe there is a lot of publications. There is a lot of new knowledge. There might be, we might be ambitious by getting this meeting on. But it's a bet, it's a challenge, and I hope that will result in concrete outcomes useful to the emergency management community and to the national tsunami warning centers. Many thanks for the question.
Okay, Bernardo, thank you very much. And my apologies if I was speaking Spanish earlier, I didn't realize. I realize there's a number of participants that may not be fluent in Spanish. So, okay, I would like to say a few more things about the goals and objectives of the workshop. I have a talk right before lunch, and then I'll be a little bit more specific on things that are really, really important. Some of the outcomes of these workshops are really important for tsunami modelers. I'll talk a little bit more about that. And so our next speaker is Captain Andres Varea from Peru, and now we're going to hear from the organizations that really bear the responsibility for issuing tsunami alerts, and they will talk to us about how the work that these workshops bring about impact the warning and preparedness of each country. And then we'll hear also from Captain Carlos Zuniga and on the impacts for the national agencies with these type of responsibilities. So I'm not sure we're going to hear from Carlos first. And
it's going to be a mix.
A mix. Okay, so you have the floor.
Thank you so much. Can you hear me? See? Let me check this. Uno, dos. Ah, se escucha bien internet. No, sí, se escucha bien internet. Well, I will use the time while we're trying to connect our screen. So let me first introduce myself. I'm the commander, not yet captain. Thank you, Diego.
Okay.
Maybe in the future, who knows? Commander Carlos Zuniga, Deputy Director of the Chilean Navy Hydrographic and Oceanographic Service. And along myself is the Lieutenant Gerardo Macedo. He's in the top right in the screen. And we will give you a short talk about how the end users, we are the end users, are expecting about your work. So probably that can answer a little bit your question, sir. Because we are dealing with a very important thing. We are dealing with lives. So that is our business. And as we receive a better and most accurate information from the academia, from the seismological services, we will be able to provide better tools to the management emergency offices. Because we are here in the region of the Southeast Pacific where, sorry, I'm a little bit distracted about the situation. The Southeast Pacific region has a very interesting thing. Almost all the 4 countries, we are Colombia, Ecuador, Peru, and Chile, have this quite kind of the same situation about the organizations. So the tsunami warning centers are run by the navies, Chilean Navy, Ecuadorian Navy, Colombian, and also the Peruvian one. And we provide information for actions to the national emergency offices, like INDECI in the case in Peru, and SENAPRED in the local case of Chile. So we have different tools, different kind of tools, which provides this, sorry, I'm distracted, sorry. ¿Necesito cargarla? Ya. ¿Lo conectó? And we tested yesterday, so. So that is our organization, and we provide that kind of tools to the management and emergency offices, and they are working with the communities. So that is the usual condition that you can expect here in the Southeast Pacific region. So as it was mentioned by Mr. Aliaga, the Pacific was the first ICG, started right after the 1960 earthquake in the southern part of Chile. And since then, we have been working very closely with many other countries, but in the local case of Chile, we had a very important change after the earthquake of 2010. And since then, we have a very close relationship with the academia, and as service, we request and we need information from local sources. Because in the case of a distant, of a far the source of tsunami, we rely in the information provided by the Pacific Tsunami Warning Center. However, for local events, we demand information from our countries. Using that information, we are able to provide better information to the authorities. So during our presentation, we will be back and forth with Lieutenant Macedo. We will try to explain how our, no, that is not the right one. No, I'm not Commodore. I'm not. And also, I'm very happy to be here, and I would like to thank to UNESCO, also to the Universidad de Tarapacá, because I born in Arica. So I'm very happy to be in my hometown city, as Dr. Lagos as well. We are very happy and proud to be in this university, because we think that we are, if we are looking for solutions, for answers of any specific region, we must be in that place. So that is the reason why, as organizing team, we try to do it here or in Tacna, and we were happy to receive the meeting in this beautiful city. So that was all. Thank you so much. No. So sorry. Okay. So I will start with the Chilean condition, how we are assessing the tsunami threat in the case of Chile. We have the Chile Navy Hydrographic and Oceanographic Service has their headquarters are located in Valparaiso, and we have our operational room over there. Many of you have visited the room, and that is where a team of around 13 people are on duty, on watch, in order to receive the information and also to release the tsunami threat assessment to the whole country. So we say that we work in 4 different pillars: advanced technology systems. Also, we have a very high level of training. We simulate every day for a tsunami in the country or in any other part of the Pacific. And that is very important thing, because as we train as SHOA, also we have many different opportunities to train as well along the Seismological Center and with SENAPRED. And in some cases, I will say twice a year, we combine that kind of exercises with evacuations, which is a very good opportunity for the communities to be prepared for a real event. Also, we have redundancy as one part of our pillars. And of course, if you are trying to have a good level of technology, a good level of redundancy, you request for a very high budget. And that is something that we need to discuss every time with the authorities, with the Navy authorities, and also with the government authorities, in order to receive our budget. We have many different systems around the country which demands a big budget. And of course, we run our procedures as part of national protocols and as well as part of international protocols. As we had many experiences of tsunamis, we were able to provide also our experiences, and those has been part as well of the PTWC and many other countries of the PTWS community as part of their national protocols. So our experiences has contributed to the international platforms. And we have a Decree Supreme from 1966, which which give that responsibilities to SHOA. So we have 2 rooms, the main one in Valparaiso and the alternative in Viña del Mar. Those are very close to each other, around 20 kilometers. And probably you can ask, oh, what if we have a massive event in the central part of Chile? Probably both of them will be destroyed. But, you know, it's again about budget. We don't have the budget to run one office in Valparaiso and another one in the southern part of Chile. It is very expensive, and also you need manpower, people able to provide 24/7 duty watch on each room, so that is quite difficult to us. So if we move to a regular condition, once we have a local event, we rely in seismological information from 5 different centers. The national one, CSN, Dr. Barrientos here, he's the director of the CSN, and also we request information from NOAA, two times NOAA. One is the PTWC located in Hawaii, and the other one is the National Tsunami Warning Center, which is in Alaska, and as well the USGS, and finally we have the GFCET. Why we don't request information from our neighbors? Because we are getting information from local sources, from CSN, and also all the other 4s are providing information from the whole world. So that is a very important thing. Because as CSN is giving information from Chile, and probably from from the borders of our country. It's the same condition from Peru, Bolivia, or Argentina, which centers are looking specifically at their own territories. Once we receive that information, we assess the tsunami threat and we send that information to the authorities. That is a very important thing in the national concept. We assess the tsunami threat, and Senapred and other institutions are in charge to provide information to the public, which is an important topic. And as well, we have the Southeast Pacific Cooperation and the IOC sea level monitoring, which connect us with a sea level monitoring network very robust around the world. We have 4 different threat levels. All of those are linked to evacuation plans run by Senapred. And I will say that once we have a minor tsunami threat level, only evacuation is demanded for the coastal areas, and for bigger tsunamis, the evacuation plans are to the 30 meters above the sea level. That is our national conditions, and it's a rule for the whole country. We don't have specific rules for different regions according to their specific geography. Because if you see Arica, especially in the area of Chinchorro, Las Machas, where the 30 meters sea level height is very, very far away from the coast. But you have other cities, like I would say Valparaiso, where the 30 meters is very close to the shore. And for monitoring, we have 47 sea level gauges, and also we have 5 dart buoys. That was a contribution of NOAA in the beginning with PML. Dr. Arcas was part of that MOU in the beginning back in 2015. Chile was the first country to receive the 4G sensors, and those are deployed in the country, as you can see here in the picture. So if we move to the actual condition of our system, we have the timeline. Once we have the earthquake, we start requesting information from different centers, from intensity and also magnitude. And once we receive that magnitude, latitude, longitude, and depth, in the beginning, we have 5 minutes in order to release our tsunami assessment for the whole country. Right now, we are using only magnitude, and also we are using, since I will say 1 month, we are using phase W for the first actions. So once we receive that information, we feed our decision support system tools, and in those 5 minutes, we release the tsunami threat assessment to authorities. After that, we start working with our maritime authority, which are located in the whole coast, receiving information of tsunami effects, and also we have the 47 sea level gauges, which are providing data of the tsunami height. We start doing all the monitoring, and after that, probably maybe a couple of hours, maybe more than 12 hours, once we are filling all the request for cancellation, we provide the technical cancellation to authorities, and once again, it's part of their responsibility to tell to the people to be back to the shore. So now I'm giving the floor to Lieutenant Macedo. Please go ahead. Gerardo.
Thank you, Commander Zúñiga. Good morning, everyone. Could you hear me?
Yes, thank you.
Thank you. So I'm glad to be here to share this information from Peru. I will start with a brief introduction. First, the Peruvian Tsunami Warning Center. It's below the Directorate of Hydrographic Navigation, which is also below the Peruvian Navy, as well as Chile. Next one, please. So it's important to say here that the Peruvian Tsunami Warning Center, led by the Peruvian Navy, it's member of the National Tsunami Warning System, which is integrated by 3 institutions, which are the Geophysical Institute of Peru, the Peruvian Navy, and the Civil Defense Institute. The Geophysical Institute of Peru is in charge of receive the seismic parameters. They have a seismic network in Peru. They have a lot of sensors over the Peruvian territory. They analyze the data, and they give the Peruvian Navy the magnitude and the parameters of the earthquake. With that information, we also analyze and we determine if a tsunami is going to impact our coast. And finally, we share this information to the Civil Defense Institute, which is in charge of the dissemination of the information, but also to activate the evacuation plans in the Peruvian coast in coordination with the local governments. Each institution has, according to our standard operating procedure, 8 minutes to issue the bulletin. Also, we are part of the working group of the tsunami warning for the Southeast Pacific within Colombia, Ecuador, and Chile. Another tool that we have and we develop is the tsunami inundation maps. So this is very important because this is part of our outreach and education to the population, because they could know beforehand if they are living or working or doing some activities in an inundation area. So, and they already know the evacuation routes and where to go in case of a tsunami in our coast. And another activity that we do like every year is the dissemination and awareness campaigns. We have we hand out education material. We have some. We educate the population in the whole coast, but also we developed a mobile application, which is the MGP Tsunamis, and we have more than 100,000 downloads of this application. And in this application, population can see in real time where are they located, if they are in an inundation map, and also they can receive the bulletin of the Peruvian Tsunami Warning Center in real time to evacuate a hazard area. Next one, please. In this slide, I want to share the communication system that we have. We have different communication redundancy to assure that the communication will reach the institutions and finally the population. For a local tsunami, we receive the information from the Geophysical Institute of Peru. We have several communication systems like email, phone, satellite phone, etc. And for a distant or regional source tsunami, we receive the information from the Pacific Tsunami Warning Center. We use the aeronautical fixed telecommunication network, which is a very old system, but it's very robust. So it assures that the information comes to us. But also we are upgrading this system to the AHMS. We also have the satellite phone, and once we receive the information, we issue the bulletin of tsunami hazard to the Civil Defense Institute to activate the evacuation plans, but also to the government authorities. So in this way, with this redundancy, we assure that the information can reach us and reach the authorities in charge of the evacuation. Next one, please. Next one. Okay. So in this map, this is Callao in Peru. So we are located in La Punta, Chucuito, which we have the main Peruvian tsunami room. And we have a mirror or an alternative room in Bellavista district, La Perla district. So we are sure that we can continue analyzing the tsunami, the behavior of the tsunami, if the main room, for some reason, falls. So it's important to say also that the alternative room is in a non-inundation area. Next one, please. So what are our challenges? We will see now some possible sources of local tsunamis. We already identified several seismic gaps in the northern Chile and also southern Peru. In this case, we can see that we have a seismic gap in the northern Chile, and there are some studies that already prove that after the earthquake in Pisagua 2014, just a segment of the fault was ruptured. So we can conclude here that we expect a large earthquake because we have accumulated energy in this area. We can see the red and black areas, which we have the seismic gap. Next one.
Thank you, Gerardo. So another challenge for us as National Tsunami Warning Centers are the rupture model. Because usually, or in the past, I would say that we started working with uniform faults. And we know that there is a very, no, not very, sorry. We know that it's a tool that is very useful and it can give us some ideas of what we can expect for a tsunami. But what we know, that is not a real fault. So we can have many different kind of configurations, but that one is one of the less probable, or maybe it's impossible to have one of those, but it is something for starting, and that is the idea that we start using late in the 90s, and that is the information that we use for our inundation and flooding maps, which was a first step. But then we are moving to these times, and we know that we have more tools. We have more knowledge about what will be a more realistic rupture, and we are demanding from the scientists, from researchers, from the academia to have a better understanding of how a realistic fault will be in this specific part of the continent. Because we need to feed our systems with that kind of tools. Since for Chile, we have our system that is fed by pre-model events, but if we have a kind of stochastic scenario for our system, that will be a better solution. However, it's important to understand that once we have this kind of stochastic events and probabilistic events, the next step is what we can do with that information. How the authorities will manage that kind of information. Because we can go to the most destructive event and probably we will see a tsunami inundation far, far away from the coast, or also we can go to the smallest event with almost no inundation. So that is an important step to move forward. Since we are in the position to have stochastic events, but what we will do with that information, and that is a good question for us, because we can start giving solutions, but for what? That is the question. For what? For what is useful that kind of information that this kind of meetings might provide. So in the Chilean case, we have CIPAT, which is the baby of Dr. Patricio Catalan. The baby is almost 7 years old right now, so it's in the primary school already. And we have our system divide the country in 21 different blocks, using mainly the political divisions of the country. So Arica and Parinacota has its own block. And that system is fitted by plus 9,000 scenarios, but those scenarios can be stochastics in the future, probably. Who knows? That is something that we need to understand and to give the answers of what will be the future of this kind of tools. Since we have a better background of the system, we will be able to provide a better solution for authorities, and that will be probably better evacuations. We might save more lives. We are not closing areas that probably those won't be affected by a tsunami, but those are many questions that arose for these solutions. And just to let you know, this system started with a very close collaboration with JICA, the Japanese International Cooperation Agency, DLR also from Germany, and as well with the University of Santa Maria. And after that, SIGIDED took the whole system and helped us to this kind of results. A solution by a segmented country, which is, I will say, a good tool for a country like Chile with a very long coastline, more than 6,000 kilometers from here, from Arica to the south, which is a very demanding scenario. And also using that kind of solutions, that kind of faults, we were able to run this inundation floating maps, tsunami floating maps. And actually we have 70, all of those are in our website. We don't have a tool as DHN, which they have its own application for mobile phones. We only have the inundation floating maps in our website, but also they're able to be downloaded and used in Google Maps, which is very useful. And well, we are seeing there the inundation of Arica, and I give the floor back to Lieutenant Macedo.
Thank you, Commander Zuniga. Continuing with the presentation, we can see here more seismic gaps in the southern and central Peru. The Geophysical Institute of Peru published this map several years before, and they identified some seismic gaps according to the map that we are seeing here. And this is between the Peru and Chile trench, and we expect earthquakes between 8.5 and 9.0 in all this area. This information was also validated by some studies from paleo tsunamis that occurred in that area. And actually on the southern coast of Peru, we have 21 tsunami elevation maps. In total, we have 131 maps, and we expect it to develop in the next 3 years more than 200 maps. Just in the southern Peru, we have around 50 coastal towns which with this benefit, which is very important, as I said, because they can know beforehand how to evacuate. These evacuation maps were elaborated with the tsunami Japanese N2 model regarding the historical tsunami from Arequipa in 2001 and also the tsunami in Arica in 1868. Next, please. Finally, before finishing this presentation, I would like to express my feelings of gratitude and appreciation to UNESCO and IOC for this important meeting that address this threat in this part of the world. and which is really important because it will help us to improve our tools and to face this problem more properly. As well, consequently, this information, these results will help us to save more lives, which is our core business. Thank you very much.
That's it.
Tenemos 5 minutos para preguntas. Si hay alguna para sí, para el capitán Carlos. Sí, Patricio.
Good morning. Thank you for the presentation, both. It's great to see them working side by side as the slide that is on the screen right now. One question that we have discussed before, but perhaps to get the discussion going, there is a lot of efforts trying to get more reliable information from the source, but yet always the source is going to be subject to some level of epistemic uncertainty. What do you think is going to happen with pre-computed databases once we become more confident in sources or in source retrieval? You mentioned that now WFACE is implemented officially. Are we going to get rid of those, or how do we stack the process with better information?
I would like to have the answer for your question. But the thing is, actually our system, I'm talking about the Chilean case, our system, once we receive the initial information of the earthquake, the magnitude and location and depth, we identify some candidates in a specific window. So probably if we are receiving a more reliable source, maybe in the beginning that window can be reduced in size. That will be an improvement of the system, because actually we are seeing too many candidates which spread out the tsunami for the whole coast, and that of course is the final resort is to have a higher tsunami height expected in the coast. So that will be one step. But then maybe the future will be to use a single solution. I don't know. Once I'm saying that, I remember the case of the 2011 Tohoku event, that I'm pretty sure that it wasn't the actual problem, but also if you rely on only one information is a symbol of vulnerabilism. So I wouldn't move to that, but I have many ideas in my mind, but not the final answer. But that will be a very good step to move forward, I would say. Probably you have the answers.
Something we can discuss during the 3 days.
Any other questions for Commander Carlos? Say that again.
May I have a question?
Yes, go ahead.
Yes, thank you very much to both of you for this nice presentation. And my question is regarding what you said previously. Most of the, if I understand well, most of the inundation charts from Shoah are based on historical scenarios. And for these scenarios, obviously, we know the run-ups and we have many data. But more and more, scientific research and paleo studies are finding some cases in what those historical scenarios are not enough. And some paleo tsunami research and paleo seismic research is showing very important scenarios for northern Chile, for example. We are going to discuss about that. And my question is, how are you available? Are you able to include these scenarios from paleo records in this tsunami hazard assessment? And have you some ideas how to include it in this risk inundation charts, for example, or something like?
Thank you for the question. And Gerardo is very lucky because he's not here, so I'm receiving all the questions. So, yes, in the beginning we only used historical data. And the first inundation maps for the country was here in Arica. That was back in 1996, I will say, and probably it was part of the historical one. But we started moving forward to using that kind of information, and actually if you see the inundation maps for Valparaíso, the data from the event of 7030 is used. Yeah, that is historical as well. Yeah, you're right. So we don't have any paleo tsunamis. However, we start working closely with the University of Chile, and that I know that is not paleo tsunami as well. But we receive parameters for around a couple of thousands events or realistic events that we might have in the coastal area, and we are using that information for our inundation maps. Those are not paleo tsunamis, but those are realistic events which are huge earthquakes. Many of them are magnitude 9 or higher, so as I said, it's not a paleo tsunami, but probably it can be linked a little bit with worst case scenarios. But the other tool that we are thinking of are probabilistic hazard maps. That will be also another way to see the hazards, and also another kind of tool for planning, city planning, and that kind of topics that also are very important for this hazard.
Okay, thank you, Carlos. I think we have one more question from Bernardo. He has his hand raised online. Yeah, go ahead, Bernardo.
Yeah, thank you. There was some echo.
We can hear you well here.
Okay, yeah. I just wanted to contribute to the answer by Captain Carlos Zúñiga, not yet, Commander. You know that's very hot in France at this moment, so I take the opportunity to take out my jacket. But the case to be mentioned here about that question is the 2011 Tohoku earthquake. There were studies in that region that were saying that 800 years ago or 900 years ago there was a big tsunami that was not in the horizon of GMA. They didn't have that case in their database. After the event of 2011, they modified their tsunami information products, and they moved into a three category tsunami for inundation or alert warnings, national warnings: 0 to 1, 1 to 3, and over 3. And that was a change that was generated by that uncertainty. So that's the way they responded to that possibility, I believe, and it's something to consider when you are facing that kind of potential that is the best expert judgment about the potential for a higher tsunami than those that are in the databases. To have the over 3. But in your case, it will be over, I don't know, over 15. Okay, thank you.
Okay, thank you, Bernardo. And I would like to add that the inclusion of these paleo tsunamis or evidence of this is one of the objectives of these workshops, is to try to bring the experts to identify those so that the information that's contained in that evidence is included in the inundation mapping. So so it's really along the lines of what we're trying to get accomplished here. And then Commander Suniga brought up also the issue of how to handle that information in real-time warning, which is a different bag of beans from designing an inundation map. I mean, you have very limited time there, and you have to respond to a specific event that may relate to the worst case scenario that you may have used or not. So those are topics that hopefully can be covered during the workshop, and there's being a number of workshops similar to this celebrated with different lengths in time, and there's been more or less time for discussion on these related topics. So we'll see how much time we have here to discuss that. And we will address that after the break that we're going to have. We're heading now to take a group photo for the meeting, and then right after the picture, we will have a coffee break, a 30-minute coffee break, and we will be back here at 11:15, and we'll continue with the talks then. Okay? Thank you very much.
Sí, está desarrollado el módulo. El módulo está basado en el programa de Diego. Sí, de la Universidad de Orlando, pero es el que está poniendo
Vamos a la foto, distinguida. ¿Sabes que lo voy a acomodar aquí mejor porque se ve mejor acá? Ahí.
No, se ve mejor.
¿Ah?
Para efectos de...
¿Sí? Ah, ya, aquí. Ya, ok.
South American plate. And we have here on ellipses the latest seismicity, the latest historical earthquakes. And in particular, we see the longitudinal extent of the earthquake in the panel on the left. And from 1500 years up to a few years ago, 2014, where there was the last large earthquake in that region. So something common is that this place is struck by devastated earthquakes, and most of these earthquakes generate a large tsunamis. And one characteristic that has been found lately, not only here but for several earthquakes, that sometimes those large earthquakes are preceded by some anomalous seismicity or deformation process that occurs within a few days, a few weeks, or a few months. And a paper that is basically stating one of the first findings here is from Ansoke that we'll talk, I think, tomorrow in this part. So we have this seismicity here, and I'm going to focus on two main characteristic events here. That is 1877, that defines a seismic gap in northern Chile, and 1868, that defines a seismic gap in southern Peru. So the 1877 earthquake defines a seismic gap in northern Chile. It has magnitudes that depends on who you ask, basically, but varies between a surface magnitude of 8 up to a moment magnitude of 9, basically, or tsunami magnitude of 9. On the other hand, this gap that defined this earthquake was partially broken by two events. On 2007, the Tocopilla earthquake, and on 2014 the Iquique or Pisagua earthquake, but those earthquakes just ruptured a little bit released just a little bit of the energy that is being accumulated in the region since 1877. So the hazard for a large earthquake in that part of the world is still high. If we go to southern Peru, there are several earthquakes in this part. I'm just going to talk right now about the 1868 earthquake because it occurred closer to the limit between Chile and Peru. And basically, it was an earthquake that may have been between a magnitude 8.6 to 9.1, depending on who studied the magnitude of the earthquake. This is a historical earthquake, so basically there are not much instrumentation available. And on 2001 occurs a magnitude 8.3, which is the Arequipa earthquake, that releases a large amount of energy, but still it's believed that there is still part of the energy that is being accumulated since 1868 that hasn't been released in that part. So we have this nice seismic gap that should be one between Chile and Peru. And I won't go into detail of every historical earthquake just because of timing. But the ultimate goal here will be to achieve some improvement on seismic and tsunami hazard knowledge. And there are two approaches that we can see. You're going to see today a lot of talks about historic and paleo-tsunami investigations. And we're going to talk here about the modeling approach and basically how to improve the tsunami hazard or the seismic hazard, thinking about the tsunamis that are generated by earthquakes and forgetting a little bit about the other sources of tsunamis. Basically, as a way to understand the seismic cycle, as an excuse to understand the seismic cycle, because it's where the strain, the energy is being accumulated that is eventually released as a large earthquake that generates a large tsunami. So in this modeling approach, basically we have here an animation that depicts a simple cartoon of the seismic cycle, in which we see the oceanic plate, the continental plate, and these plates are stuck in the interface up to some point where the stresses accumulated and the interface are large enough to produce a sliding, an unstable sliding. So if we look at these dots here, these gray dots are instruments, geodetic instruments that, for example, a GNSS. And during the interseismic, the period where the energy is being accumulated, you will see a trend like that, most likely a linear trend. And just before a large earthquake, sometimes you see some transients that can last a few days, a few months, and that can be some slow sleep event, could be noise, could be other signals, could be a cascade of smaller seismic events that produce the deformation. That is still open for debate. And then you see the co-seismic and some post-seismic relaxation process. The thing is, the different stages of the seismic cycle, interseismic, co-seismic, post-seismic, and some may be precursory activity or slow sleep events that may occur or not before the large earthquake, can give you insights on basically what are the frictional parameters or what is the mechanics of the subduction interface. And if you look at this figure extracted from Thornley, a paper from Thornley and collaborators from 2012, it describes that basically there are different domains within the plate interface that have different characteristics that are supposed to be more seismic in the sense that are more brittle, or more aseismic, the white part, in the sense that will just like to be sliding steadily across time without accumulating stresses. So the question is, well, using geodesy, can we say where is this elastic crustal strain accumulating on the upper crust? Or where is the stress building up at the megathrust that will give us some image or some information about where may be happening the next large earthquake in the region? And basically, we have to characterize the mechanical behavior into a brittle part that can accumulate the stresses and a ductile region that likes to move slowly over time. So in this part, so we can take this time series and look at this blue part and calculate the velocity with the linear part, and we can make some arrows like that indicate at the velocity in the long term at the crust is moving. And we can make a physical model, for example, a simple elastic model or a more complex one with finite elements, and with a good inversion code and uncertainty characterization. And we can obtain maps like that, which are coupling maps. We will see tomorrow a lot of them, I think, and between today as well. Basically, it says where are the stresses higher. So where the plate is being locked, the two sides of the interface is being locked, basically. So these are good candidates for being the places for the next earthquake, and we can see this is the co-seismic of the Pisagua earthquake on 2014, and it occurred mostly in a part that is highly locked with the yellow to red colors. So there are many models available of coupling models for Chile and Peru. Here we can see for southern Peru, basically the work of Mohamed Chli on 2011 and collaborators, and an updated model from Villegas Lanz et al. 2016. And for northern Chile, people like more working in the desert there. It's easier, I think. And basically, there are a lot of basically coupling models. And if you see, most of these models are different. But if you integrate in a latitudinal way, basically the distribution across latitudes are more or less similar. And that's because a big problem that we have with these models. So the difference in the coupling models basically is due to different approaches to solve the inverse problem from passing from the measurements of crustal velocities on the surface to what's happening, to see what's happening on the plate interface. In particular, the choice of prior information can change a lot of the results because the problem is very ill-conditioned. And it changes also it differentiates the different models in the type, GNSS or insert geodetic data, and the amount of observation depending on when these models were built. An important common factor is that all these studies use only on-land coastal strain observation, GNSS or INSAR data, that are on land and not on the seafloor, to constrain something that's happening mostly offshore. So basically, we are measuring on this table what is happening on the other door of the room. Basically, it's difficult to measure something like that. So that results on poor resolution of shallow megatrust slip behavior that translates into high uncertainty in shallow coupling and hence of tsunami hazard, because what happens on the shallowmost part of the plate interface will be extremely relevant in order to determine if the tsunami will be larger or not, if you have a slip on the top of the plate. So basically, in order to illustrate that, here we have a cross-section of a subduction, a typical cross-section of a subduction in Chile. And we have here in green a simple coupling model. Basically, the whole bars are fully coupled, and then it starts to decouple at 50 kilometer depth, and then it's fully decoupled. And I'm going to compare the velocities on the surface of the crust, on the seafloor and on land, against this coupling map. And the only difference between this one and the one below is that it's not coupled up to the trench. So if I make the difference of these two, basically the back slip of the coupling I get, the difference between these two models, is some coupling that starts from the trench up to 20 kilometer depth. And if you look at this panel, basically the blue is horizontal displacements and red is vertical displacement. So when coupling is occurring here, all the complexity that defines the coupling is only seen on the seafloor, which is the part that is painted blue at the background. And this is on land and this is seafloor. So the signals on land are very boring, but all the fun is on the seafloor. So in order to see the complexity of the source of that signal, we need to measure on the seafloor. We need to observe that. We cannot, if we only observe on land, we will have a very high uncertainties on what's happening here. So an ongoing example, and I'll be going quickly, will be the use of seafloor geodesy in order to better understand what's happening on the plate interface. And we'll be collocating these APGs or absolute pressure gauges. That is an ongoing project that we already installed these instruments in Atacama. And basically, we have these three instruments here on the seafloor in order to improve the resolution of the coupling maps that can be developed on the future, or the visualization of slow slip events that may occur in the shallowmost part of the subduction interface. Once you have that data, you have to use the most advanced inversion and uncertainty quantification. This basically is an example of a method I developed 2 years ago. I published it 2 years ago. And basically what it does is, even if you don't have data on the seafloor, it will give you stable results, in the sense that it will average over a larger region. It will recognize what is the size of the region that I can resolve and give you the result on that size. And we applied this in another publication with a student, basically to obtain a coupling map just south of the study region that we are going to see here. It's from Mejillones Peninsula to the south, and it's a very detailed map and includes a very good characterization of the uncertainties of the results. Other method that we're going to publish soon, I hope, we're going to submit it soon for peer review, is basically in the same idea. So I want to infer a slip at a certain scale, and I will use represent the slip using basis functions of different scales, and I will let the method to choose the scale at what it can resolve, but not going into details. But the really cutting-edge inversion, and speaking, Captain Zúñiga, Captain Zúñiga, and I totally agree, we should do a stochastic simulation. And in order to do a stochastic simulation, we need to do coupling maps, in this case, that are used are obtained using a stochastic method. These are Bayesian sampling techniques. So basically, this is an example of a coupling map that we just published for the Atacama segment, and we're working on doing the same on the Iquique segment, which is basically northern Chile, the big north from Mejillones to up to Arica. So in summary, basically we're posing kind of questions here. We need to use seafloor geodesy. What is best depends on the budget, and these are methods that are very expensive, so we require external fostering for international research projects and funding acquisition. And there are several options that go from these pressure sensors, acoustic GNSS, maybe use the OVS, because we need to characterize well the seismicity that is occurring near the trench, and use submarine cables with the same purpose. And you can see Diane Rivet's project on Geasur, that is very well developed project. And in the modeling side, we need to use inverse method with less bias, which is ideally this Bayesian sampling approach. But in order to use measurements that we're going to make on the seafloor, ideally, we are going to need to improve our forward models. We cannot use Okada, we cannot use a half space anymore, because we are putting a slip very close to observations and the model is not accurate. We need to incorporate at least the topographic effect on the Green's function we're calculating for the inversion, and account for uncertainties on the physical forward model, elastic structure, or other parameters you can have, and quantify in a robust manner the results of the inversion. Basically, we have to include as well, mix this coupling approach that we will have a coupling model and derive tsunami scenarios from this coupled model. And Ignacia Calisto knows how to do that, and I think he will mention that in her talk. And we should update the existing coupling models, because we need a coupling model that spans Peru and Chile, because there are other processes on the upper crust that need to be incorporated as a whole. We cannot do this separately. We need to include this deformation process or rigid motion process that are occurring on the upper crust in this case. In the other hand, well, we need to define if we are going to talk about early warning efforts, and in that case, well, do we need more dart buoys? Because we have dart buoys on the Nazca Plate, we have the mareographers on the onshore, just on the shoreline, but we don't have anything in between where is the tsunami being created. So we need to do research and development, or maybe instrumentation that has used remote sensing approach in order to get a broader spatial coverage, and then Ignacia Calisto from UDEC is doing something like that. So we need to state the fact that earthquakes and tsunami do not know about geographical borders. That is important. That's our problem, not theirs. And we need to recommend, basically, when we do the recommendations of the work, we need to recommend international articulation and collaboration and fundraising. We need to have made available research projects that are targeted research projects on areas of interest, but that groups from both countries can apply to this funding and work as a team based on that funding. And thank you very much. Te lo dejo puesto.
When finished, have the main questions. Okay. No word? No word. Okay, thanks for Francisco to his talk. It's very interesting to see some relationship between what? Sorry. Where? Okay. Ah, this is not mine. Let's see. It's okay. Okay. Well, my presentation is related with the tsunami hazard estimation. What is the problem? Okay. To analyze the tsunami hazard estimation using some approach related with historical what is the problem with this? I don't know. No, it's in the computer. The last chance. Okay. With very careful. Okay. This. Con la flecha. Okay. Oh, I don't. I don't touch anything. Ahí está bien. ¿Cuál puede ser el problema? ¿Está mal? No, ya. Ya, ¿dónde tengo? Las dos. Continuamos con, mientras solucionamos, continuamos con Alexander. Continuamos con Alexander mientras solucionamos. No tengo PPT. Solo PDF. ¿Y habrá otro laptop que pueda probar? ¿Qué? Este también. A ver. No está en un pendrive ahí. Sí, mientras yo lo arreglo con mi computador. Sí. Lo cambiamos. ¿Con este me conecto? Que presenta Alexander mientras solucionamos. Voy a traer mi computador y cargo directamente a la presentación, ¿le parece? Ya.
Sasha, are you online?
Yes, I am.
Okay, so you can see that we're having some technical difficulties here. So if you don't mind, can you go ahead with your presentation now, and then we'll have.
Yes. Okay.
Thank you.
But it is written that I cannot share screen while other participant is sharing.
We're taking care of that, Sasha, right now. We'll free up the screen for you to share.
Buenos dias, Diego. I have not seen you for a while.
See this before the pandemic, and I'm still not seeing you. Hopefully, I will be able to see you. There you are. Yeah.
Alexander, I think that you can now share your screen. Alexander,
okay.
Go ahead.
Can you try?
and share your screen.
Is it okay?
We can see you, but we can't see your screen.
Okay.
Can you try to share your screen?
Just a second. Oh. The Murphy's law, you know. Okay.
Okay. There you go. We can see you now.
Near there. You need to go into presentation mode now. Display or presentation mode.
Just a second, sorry. Oh. Once again, I don't see this. By just in case,
you were very close. It's just on your left. There's an icon that is presentation mode on your PowerPoint. That's the one that you need to use.
There you go.
Yes.
Okay.
Go ahead.
Is it working?
Now, remember display settings. Top bar. Second tab.
Okay.
Yes, correct. Here we go. Perfect.
Okay.
You are on.
I'm sorry for the problems. Buenos dias. I would be happy to be in Arica, but just now I am in Victoria. But I will try to do my best to share my presentation with all participants. And first of all, I would like to say that most of this work was done approximately 20 years ago. That means that it is a little bit old, but at the same time, what is good, we worked specifically on this region, southern Peru and northern Chile. And I understand that some of the results probably are quite old, but at the same time, I believe that approaches are approximately the same. So, as I said, mostly we worked as a team about 20 years ago, and in 2001 we published this paper related to estimation of tsunami risk for the cost of no, something. Sorry, something is totally wrong. Okay, I'm sorry. Just a second. Okay, so is it okay now?
No, we don't see any presentation. You need to, again, share your screen with the right PPT.
Okay, you're sharing the screen now. And now go to presentation. There you go.
Is it okay?
Yes.
Or,
Yes, we can.
Yes, I think that it is.
Okay, so we are talking about one of the most active and most dangerous regions. And you can see from this map, we have lots of earthquakes, terremotos here, and certainly they can produce very strong tsunamis. And we can divide all types of tsunamis possible in this region into four different types. One type is local tsunamis, like it was 1868, 1877, some old like 1604. Certainly they are most dangerous, but at the same time, we have also some tsunamis, regional tsunamis that are coming from the area of Chile and from the area Ecuador. We also have some transoceanic tsunamis that are coming from the opposite side of the ocean. And also we have some non-seismic events. We should definitely take them into account. I'm talking about landslide-generated tsunamis, volcanic tsunamis, meteorological tsunamis. But just now I would say that for this region, this is almost terra incognita. Quite little known about these possible tsunamis. Okay, and in our study, we based on some old catalogs and different reference data. I probably would say that most important was this catalog of Silgada and Lomnitz, and also old catalog of tsunamis by Lockridge. And what is the most important? We used two tsunami databases. One was from the National Geophysical Data Center in Boulder, and another one was from Slava Gusikov, who is online here from the Expert Tsunami database. As I said, we published our first paper in 2001, and that time we tried to estimate the areas of the highest risk, and we used the paper of Kelleher, who used the seismic gap theory and tried to predict some possible areas. And when we published our paper in the beginning of 2001, we actually expected that the area of the highest risk and possible strong earthquake will be here. And this was totally true because a few months later, specifically in this region, occurred an earthquake with magnitude 8.4. So then, based on all our knowledge, all our data analysis, we published 2 papers specifically related to this region. I would like to emphasize that our study was, and the main purpose of our study was to estimate tsunami risk for this specific region based on statistical analysis of data. We have not used any kind of numerical modeling, but we tried to accumulate all possible statistics, because what was quite important for us to estimate the probability of tsunami events with different return periods. And our first approach was to use statistics of earthquakes and some empirical relations between the magnitude of the earthquake and possible tsunami wave heights. And we, for comparison, we used 3 different relationships by IIDA, by ABA, and by Selgada. Selgada tried to estimate specifically for this region. And in this table, we have our estimates of possible maximum tsunami wave heights for like 10 years, 20, 50, 100, and 200. And you see that actually we have quite different numbers, especially for long return periods, depending on specific expression. But we know that all this expression and all these relations between the strength of the earthquake and possible tsunami wave height are very inaccurate. So we then try to use statistics of specifically of tsunami runoff. And here in this map, we accumulated all known tsunami runoffs for this specific region. And actually, we see that more or less this distribution of possible tsunami wave heights, except for this region, is more or less like uniform. Here are examples of 4 strong events and known tsunami wave heights for these events, for this course. So we know that one of the major problems is some historical events. We have, for earthquakes, for tsunamis, we have relatively good statistics for last 100 years, but historical events are not so well known. So here, 2 estimates are presented. One was based on 450 years, and sorry, here is certainly a mistake, not from 2001, from 1901, for 100 years. So you can see that actually for relatively short return periods, we have we have significant difference. It is clearly seen here, but for long periods, we have approximately the same. But also what was quite important for us to compare 2 tsunami databases. So in our second study, we just tried to do these estimates based independently on 2 catalogs. And you see that for relatively short periods, we have almost the same numbers. But when we are going to larger periods, the difference is quite significant. And the main reason is that there are some differences in historical events with estimates of historical events. I'm talking about events that go about like 400 years ago. And this is a key point in all statistical estimates of tsunamis, just this. Okay, so all the study, as I said, was done about 200 years ago, but actually after this, there were several more strong events in this region. First of all, I'm talking about 2010, 2014, 2015, and so on. But also there were some transoceanic events like Sumatra, Tohoku, and Tonga. And I just would like to show you some our results related to estimation of observed maximum wave heights for the coast of South America and results of numerical modeling. This study was done in cooperation with the Pacific Marine Environmental Center. These results of numerical modeling, what is the most interesting? We have some kind of convergence in this region. So from Sumatra, one wave, we call this Atlantic wave, came through Drake Passage from the east, while in another wave, the Pacific wave was coming from the west. And here we have amplification of tsunami waves just because of these two waves. Tohoku, we have not done any specific study for the coast of South America, but at least I can show you some statistical results. I would like to emphasize that here are amplitudes. Before we were talking about wave heights. And what is quite important, so wave heights will be 2 times larger. But what is important, even this remote event, Tohoku event, can produce very strong response for the coast of South America, in particular for the coast of southern Peru and northern Chile. You see that wave heights in this area were up to 4 meters. And last event, Tonga event, very specific event. Actually, we estimated possible tsunami, observed tsunami amplitude for the entire world ocean, but here is our specific interest to the coast of South America. And actually, you see that this, just for this coast, tsunami wave heights, your tsunami amplitudes were maximum. You can see here. And just some examples of this recent tsunami for the coast of South America. Actually, you can see that amplification of waves occurred specifically in this area. To the north, wave heights were much smaller. In particular, you see that in Callao, it was wave height was almost 2 meters, and in Caldera and so on. Here are some results of our observations for some island stations. It was quite interesting for me because I was there in October last year, so specifically at these 2 sites where these measurements were done a few months before. And more or less that is all. And I would like to say muchas gracias and thanks.
Maybe we have time for 1 or 2 quick questions for Dr. Rabinovich while Juan prepares for his presentation. Any questions for Dr. Rabinovich? there's one question online. I think it's with Jacob.
Sasha, muchas gracias por su presentación, muy informática. Pero tengo una pregunta. On one of your slides, you said that South America coast in the area between Peru and northern Chile are subject to impact of three types of tsunami: local, regional, and transoceanic. I wonder how do you divide South American tsunamis from this area in these three groups? What your criteria?
You know that actually it was done just because it was convenient for us to divide local in closed area, and I just showed that close area to the border between Peru and Chile, maybe approximately like 300 kilometers to both sides from the border. Some earthquakes that were located along the coast of South America, but for larger distances, were called regional, because the effect was actually weaker than for local events. And some events like Kamchatka, Japan, Tonga, and so on, they were transoceanic. So tsunami waves that are coming from the opposite poles. Maybe Alaska we also can call transoceanic.
Okay, thank
but
you.
In any case, these last events of Tonga and Tahoe, they clearly demonstrate that we should take such events also into account. The advantages for this work.
Okay, thank you very much, Sasha, and stay tuned if you can. We still have a long workshop, so thank you. And we have next Juan. I think he's solved the technical problems, and he can show his presentation now.
Okay, sorry for the technical problems. Well, my name is Juan Gonzalez. I am tsunami researcher at TGN, and the presentation is related with the tsunami hazard assessment in the southern Peru and northern Chile seismic gap. The idea is show some different approaches, an historical approach and numerical approach, to try to analyze the different type of sources in this area. The motivation of this work is related, but in the upper panel, you can show some photos related with the post-tsunami survey in 2014 earthquake in Iquique, and in the upper plate, in the upper pan, in the other panel, you can show some gravings about the 1877 earthquake in the same part in Iquique. Okay, well, the motivation is try to conciliate some historical or paleoseismological information with the actual techniques. Okay, has the key of the past is the present, and this is the motivation of this presentation. Okay, my colleague Francisco talked long about the different tectonic characteristic of this area, but well, the more important thing in this is about the 30% of the people in the northern part of Chile lives in inundation zones. This graphic show this information, and by other way, we have two big tsunamis in this area, the 1868 and 1877 earthquakes occurred in the southern part of Peru and in the northern part of Chile. But this subduction zone, this converted margin, can be capable to host a big earthquake like, for example, Valdivia. And, well, what is the approaches to talk today? Well, how you can calculate the sources in tsunami hazard assessment. The first way is when you have a tsunamigenic event, okay? You have some finite fault models and you can model the tsunami. The other way is the deterministic approach. You have many different types of deterministic. Can be historical approach using historical scenarios, stochastic analysis. And finally, you can use the probabilistic approach, like more related with the engineering point of view, to calculate, for example, damage or other things related with the design of some structures. We talk about the two approaches, historical scenarios and stochastic scenario. We can explain about what is this in this case. Our historical approach can be focused in the two last tsunamigenic earthquakes using some old marograms recorded in transoceanic sites in the Pacific Basin. Well, this is some information about the different analysis of the historical megatrough earthquakes in this area. In the case of, for example, 1878, Causel proposed, for example, a magnitude of 8.8, and other researchers like Ocal proposed a very big earthquake, 8.3. In the case of the northern part of Chile earthquake, the last analysis proposed by Vigny and Klein proposed a small earthquake, about 80.5, with a longitude more shorter than others approaches. Okay. Keep in mind this information and we compare with our analysis how far is about our calculations. Okay, how we can constrain the historical earthquake ruptures? Okay, we have some information about marograms recorded in United States and Australia. This is an example of this marogram. This marogram is available in NOAA archives, and we use this marogram to constrain our ruptures. Normally we have some issues about these old marograms. Probably you have problem with the amplitude scale because this recorder data is in paper. Large time errors and some uncertainties about the kind of the type of recording. This is an example of 1877 marogram recorded in San Francisco, United States. Well, when we can reconstruct these old marograms, well, the first part is digitize the marogram in the these first steps, and compare with the observer tide in the present tide gauge in San Francisco in this case. Probably you can see some lag between the two information, and in this case we try to adjust the tide as a proxy to obtain the real information. Finally, we can have this kind of marograms corrected and with the present tide regime. We have these records for 1878 in blue. We can have some records in 4 stations in United States, in Astoria, San Diego, and San Francisco. And in Sydney, we found some records about this event. In the case of 1877, we have 2 records in San Francisco and Sydney. And we can compare, for example, with others events, present events, to analyze the different signal. When you have this information, you can make, for example, some inversions. Well, first we can analyze the magnitude from the statistical point of view, and we obtain some range about the magnitude of the tsunami event. In the case of 1868, sorry, 1868, a magnitude from 8.9 to 9.2. In the case of the event of the northern part of Chile, from 18.8 to 9.3. In general, this estimation have good agreement with the upper limit proposed in the papers and in the last literature. But you can make some formal inversion about the old margograms to obtain a numerical source using some geometry with a bell-shaped Gaussian distribution of sleep in this panel, and generate different segments along the seismic gap. Our first results, we obtain a magnitude of 8.9 for the southern Peru earthquake, and this inversion can be good agreement with the all margograms data. We observe some preferred patches of to activate the sea level records, and some uncertainty about the information. But initially, this information can be adjusted to the literature reports. In the case of northern part of Chile earthquake, it's the same. Well, in this case, we have 2 margograms in San Francisco and Sydney, and our magnitude, expected magnitude, is 8.8. Okay. The other thing is we obtain a maximum peak sleep about 22 meters in this area. And finally, if you make some compilation of the events in this area, you have 5 events mainly. The 2 tsunamigenic earthquakes occurring in the southern part of Peru and northern part of Chile, is some small event occurred in the 1995, and the last earthquake of Iquique, and the Arequipa earthquake occurring in the southern part of Peru. Well, if you can see, you can compare with, for example, the Valdivia earthquake, because it's an area about 1,200 kilometers. Yeah, very similar to this last earthquake in Valdivia, but probably the rupture mode is different. Okay, probably the north part of Chile, I don't know if capable to generate a big earthquake like Valdivia, for example, but you have some segments, and this segment can be activated in some part of the seismic cycle. Okay, we finish with this approach and try to analyze the stochastic approach, but this the historical scenarios can be complementary with the stochastic approach, because a stochastic approach is a numerical technique, but we need to constrain this stochastic technique to obtain not real scenario, but plausible scenarios. In general, the stochastic techniques initiate because we have some in the present earthquake we have some problem with the rupture complexity. Okay, if the magnitude of earthquake increase, normally the rupture complexity increase. Okay, and in the case of some inundation of tsunami, probably if you use an homogeneous fault, probably you have some underestimation of inundation. Okay, and with this approach we can manage this complexity and this underestimation of intensity tsunami measures. In general, our approach is based in a Carhunel lobe expansion. Yeah, well, the equation implies some medium plane with this disturbance with some in small folds. Okay, and with this you can obtain, well, all the information is a Gaussian random field, and with this basic information you can obtain some scenarios related with the well, we have many parameters related because you need to define previously the fold geometry and some other parameters related with the models. Normally, this we can generate many scenarios using a stochastic approach, and we need to model over cluster infrastructure about well, and we have some relationship with the National Laboratory of High Performance Computing to generate many modelings of these tsunamis. Well, one problem with this is try to define a tectonic segmentation. The first is define a long strike tectonic segmentation. In this, we can show, in this case, I show two approaches. One approach used by Sayar. This is a more geological approach. And in the other case, the segmentation proposed by Molina is a geophysical segmentation. Yeah, okay, this is a two approach, and well, we need to select one or other segmentation. Another thing is try to generate some segmentation related with the down deep direction. Okay, because in the case of stochastic scenarios, a plausible scenario occurs, for example, in the B segment. Okay, it's very unreal if you have some, for example, magnitude 9 earthquake occurred in the down deep, like for example, Tocopilla earthquake. Okay, and you need to constrain this scenario using a long strike segmentation and down deep segmentation to generate plausible tsunami scenarios. Some results. This is different types of scenarios. This is an example of 10 scenarios with different magnitudes. And well, our analysis focuses in mejillones. You can see some different inundation with scenarios with the same magnitude, about 8.9. we model about 1,000 scenarios for this area. The other result is related with focused inundation in damage scenarios. For example, this is inundation for mejillones with more precision. We define for every houses in the urban zone of mejillones. And using, for example, fragility curves, we can analyze the damage probability in this area. Okay, this is one scenario. We can improve this technique using other different scenarios. Finally, some conclusions. Well, in the historical techniques, we conclude that our analysis is consistent with the information of report related with these earthquakes, but we can support with information. We can support with these all margograms that is not the typical technique using macroseismic information. These two events can be generate 8.9 earthquakes and can produce large tsunamis. In the case of a stochastic scenario, well, you can generate a comprehensive database of this information. Can be made some uncertainty analysis. For example, now we can work with cascading hazard, try to generate some relationship between a megathrust earthquake and active faults. We have a paper in tectonics published with this information, and the relationship to a megathrust earthquake and volcanoes or landslide, to understand an integral analysis of this kind of events. Well, the other is try to make some training events, a training system, like, for example, useful to the, for example, for CHOA or the DHNN, and evacuation plans and critical infrastructure. Well, with this, I am finished. I think if you have some questions, but this is the guide question of this part of the workshop. And this is my last my last slide. Thanks.
Any questions for Juan? Emil, go ahead.
I don't have a microphone, but I used to be a teacher, so I can
have a good voice.
Your name, please. First your name.
Yes. Thank you. I'm Emile Local from Northwestern University. I have first a question for the last speaker. You mentioned on your previous slides, 2 slides back, that your, let's go to your conclusions there. You mentioned that your results are consistent with shaking intensities and tsunami heights derived from historical accounts locally.
Yeah.
Now, what do you make of the case of Pisco in 1868? Pisco was completely destroyed by the earthquake and also suffered tsunami height. I don't have the, I would speak from memory, but it had tsunamis somewhere between 5 and 10 meters in Pisco. And this is why in our paper we pushed the rupture to the north, to the northwest, so that we could account for what happened in Pisco. So I understand that these are reports, these are not maybe scientific data in the form of a microgram, so they cannot be inverted and so on. But on the other hand, I think that there is still a piece of evidence which I'm not sure it is fully consistent with the models you've proposed.
Yeah, well, we don't analyze the Pisco earthquake specifically, or you talk about the evidence of in Pisco the inundation.
1868.
Yeah, I understand. Yeah, probably this can be don't consist with the with this margram, but well, we have in a first approach, we need to model these sources to obtain some in this. We have some different points. For example, in Iquique, is not really consist with, for example, 8077. Okay, we need to work in this.
Yes, okay.
But it's very good question about this this analysis. Okay, thanks.
Another thing, I don't know if I may, Mr. Chairman, but I have a question for the first speaker.
First speaker.
Yes. Francisco. Sí.
Okay.
It's Dr. Francisco. See, so you made a very good point that you need data closer to the trench, on the bottom of the ocean to study the coupling, prior to an earthquake at that location. But my question is, and I suppose it's difficult to go back to your slide, but my question is the following: when you showed the accumulation of rupture, so I fully agree that if you have a coupling which extends to the trench, to the bottom of the sea there, you should be able to detect it. But the problem is whether when the earthquake takes place, is the rupture going to go all the way or not? You could have a model where with the same amount of coupling, the top part, which may be mechanically slightly different in the contact, would not rupture. And so only the bottom part ruptures, but the top remains there. And that would make the case for a subsequent earthquake, which would be shallower, possibly tsunami earthquake, and so on. So it would be extremely important to have this data on the ocean floor, but it may not be an absolutely direct inference on what the next event will be. And for example, there is the case of 1896 in Sanriku, which was modeled by Satake and others, where he suggested that the rupture went all the way, as opposed to all the way to the floor, as opposed to a case where it's split between a major earthquake and then a tsunami earthquake. So I think it's very good, but your project is very interesting and very fundamental. But the inference about the next earthquake may not be so straightforward.
You're right. And there are two things. This part here, if you see the okay. Okay.
So a diagram with the little green blocks there.
Yeah, but this is where we put the APG on the seafloor.
Yeah.
This is the actual location. The APG is not here because of exactly that, but for two reasons. One reason is what you explained. This part here is much the mechanical behavior of the is not well consolidated. It's probably so there is an image, I can't remember the author of the paper, in Tohoku, that the shallowmost part kind of, it wasn't observed a rupture, but a kind of a mixed overturn of the material. So it's not brittle at the shallowmost part. And actually, at least in this brand of the APGs, the deepest part we can put the instrument was 6 kilometers safely, so it cannot operate like very close to the trench. But yes, I agree it's not straightforward to go from this coupling model to the rupture, but there is another reason as well: stress shadows that I forgot to mention. Because even if it were very well consolidated, the asperities may be smaller than the patches that you are inferring with coupling. So we have to be careful about that, because think of two tables and two nails. It's locked on the nails, but you cannot move the table. With asperities happens the same thing. So you have two asperities that are more or less like in my hands, very close to each other. And if they have this same characteristic size and the spacing is not longer than 2 times the characteristic size of the asperities, basically these two are going to act as a large one. And in the coupling model, it will appear as a large asperity. And there is nothing you can do about it, because it's the way the physics of the problem works. Mm-hmm. No, thank you, Ben.
Diego, may I ask a question?
I have a question regarding, coupling of using geodetic data. So how time duration impact in the results of the geodetic data in coupling or strain calculations and others? How time duration, if somebody takes 30 years data, geodetic data, or if somebody takes, I take 10 years data, last 10 years data, and I calculate the coupling modeling. And if I take not 10 years, I take 30 years data. So how it impacts in the results, in the consideration of the data sets of timing?
Think about, because normally we calculate velocities, but velocity is displacement over time. Yeah. Think about displacement, integrate the velocities on displacement. So if you have a noise level and you have a small velocity, over a small period of time, the displacement will be within noise. So you have high uncertainties on those velocities. You give more time, 3 years, 4 years, 5 years. That's a question still for the APGs. For GNSS, you need at least 2 years. For APGs, it's more kind of...
So what do you want to say? If I consider more data, that means 40 years. And in one case study, I consider 30 years data. And another case study, I 10 years data. So
you have better, and you should have better uncertainties with the 40 years data. But I think you won't gain much with more than 5-10 years data. That's my feeling. I don't know that for sure, but once you have 5 years of data, I think
10 years, 15 years, like this data are available generally.
Okay.
Okay. Thanks.
Diego, may I ask a question?
Yes, just the last one real quick.
Okay, my question is to Juan. Juan, quiero preguntar. So it is quite interesting that you have tide gauge records at the same site for several events, including 1868 and 1877, but also for some other events. Have you tried to compare spectral properties of the corresponding sites and compare spectral properties for these events, and maybe to try to estimate spectral properties of the source? And this is my first half of my question. And my second question: have you found some hot spots where the tsunami response was much stronger than for the other sites? For example, for our data analysis, we saw that normally in Callao and Arica, tsunami waves are much stronger.
Well, the first question is related with the... sorry, but I lost the...
frequency, spectral analysis of the records and estimation of some frequency properties of the records and probably of the source.
Well, we don't make some analysis about this related with the frequency analysis of all margrams. Obviously, well, this work is ongoing work. We need more analysis to define the the final information about the sources. Okay, well, this question can be good to improve our work, but initially we don't make any analysis about the spectrum analysis, for example. And the second question is?
Hotspots.
Sorry?
Hotspots. Some specific sites where the response was much stronger.
A specific site in South American part, or?
Yes.
Okay. Well, this is other part of the work because we need to model. First we model to obtain the inversion. We make some models to Trans-Pacific tsunami from the different transoceanic sites. But we need to make some models or more precise model of the tsunami in the local field. This part can be worked in this because we need to. We publish this information, and in this time we are working in these numerical models in a specific site. Like Arica, Mejillones, and Iquique. This is our local sites to make the analysis.
Okay, gracias.
Okay, thanks, Alexander.
Okay, thank you very much, Juan and Francisco and Sasha, for your presentation. Okay, so we're running behind schedule. I'm going to try to make up some time during my presentation. And so if we can transfer my presentation to the screen now. Okay, perfect. So I'm going to start with what we should have done at the beginning of the day, which is introduce ourselves. So I'm actually going to take some time to go through the room and introduce ourselves really briefly, please, because of times. And but I think it's important. And the meeting is really about seismology and tectonics and the type of geophysics that I'm not an expert on. So you can do without my presentation. So I'm going to spare you the pain of going through the whole thing. So I'll shorten it, and let's do that. So my name is Diego Rodriguez Arcas. I started working in tsunamis maybe 25, 30 years ago. I was with the University of Washington and working with NOAA in Seattle and the NOAA Center for Tsunami Research. I was there for 25 years. The last 5 years, I was actually director of the NOAA Center for Tsunami Research there in Seattle. And I left that position after the pandemic, and I'm now a consultant to them. So external consultant to NOAA. So this is my nth time in Chile, second time in Arica. I love to come back, so I was really glad when I learned the workshop was going to be at least partly here. So thank you very much. So if we, I don't think everybody knows everybody, so if you want to introduce yourself, we can go through the room and
Thank you. Thank you very much. My name is Julio Cadenillas. I'm the Consul General of Peru to Arica. Thank you very much.
Okay. My name is Cesar Jimenez. I am physicist. I am a tsunami modeler from the University of San Marcos, Peru. Thank you.
Good morning. My name is Edmundo Norabuena. I work with the Geophysical Institute of Peru. My field is space geodesy, and I'm here to talk about southern Peru seismic activity and something about space geodesy too. Thank you.
Hello, everybody. My name is Juan Carlos Villegas. I am also in IGP, Geophysical Institute of Peru, and working in the geodesy team.
Hello, my name is Ranjit Das. I'm working in earthquake hazard and risk assessment, mainly earthquake magnitude and earthquake hazard and risk assessment. I'm working in University Católica del Norte in Chile. I'm from India. Thanks.
Hi, I'm Michaela Spieske from Germany. I'm a tsunami sedimentologist, so I'm working on the paleo-tsunami deposits, but also on historical tsunamis and their deposits, and I also was part in some of the post-tsunami field surveys here in Peru and Chile.
Hi everyone, my name is Carlos Benavente, I'm from Peru. I work in INGEMED, a geological survey from Peru.
Good morning, my name is Diego Salazar, I'm an archaeologist, so I feel a little strange here. But I've been working for a little more than 10 years in the coast of northern Chile, trying to understand the historical transformation of human communities there. And since the last 8 or 9 years, in collaboration with Gabriel and James and other colleagues, trying to understand the effects or the impacts that paleo tsunamis or tsunamis and earthquakes had on the historical trajectories of these communities. Maybe we can also learn about how people were affected and how they reacted to these events as another source of knowledge to try to understand how this will affect us in the future. It's not that I'm going to make another presentation now.
My name is James Goff. I do very similar work to Michaela, tsunami geologist working on historical and paleo. I've been working with Diego and Gabriel in northern Chile for quite some time, but all around the Pacific. So when we're talking about trans-Pacific tsunamis, I think I've seen them all. And I entirely endorse what Diego says about the importance of the archaeological record, by the way. I'm associated with the University of New South Wales in Australia and the University of Southampton in the UK.
Good afternoon, I'm Lieutenant Jorge Matus. I am a naval engineer on hydrography and oceanography, and currently I'm working as the division chief of the Chilean Tsunami Warning Center.
Good afternoon, everyone. I was talking a little bit in the introduction of my presentation, so I think I already introduced myself. Carlos Zúñiga, Deputy Director of the Chilean Navy Hydrographic and Oceanographic Service.
Good afternoon. My name is Jorge Morales from Peru. I'm working in the National University of Engineering, in particular in SISMIT. I do research in tsunamis since 2014, and I also try to work from the academia with the IHA, Navy, Peruvian Navy, regarding tsunami research. So thank you. Nice to meet you.
Good afternoon, everyone. I'm Nabil Moyano from Peru. I'm physicist and civil engineering. I'm research director of Faculty of Engineering at Universidad Continental. Thank you.
Hello, everybody. I'm Rafael Aranguis from Universidad Católica de Concepción. I do many things related to tsunami, field survey, numerical simulation, and now I'm working more related to engineering design and analysis of a scour due to tsunami.
Hello, sorry for my voice. I'm Ignacia Calisto. I'm a geophysicist from the University of Concepción. Not the same. And I work on tsunamigenic earthquakes, like almost everyone here. So.
Hi. Well, everyone just saw me. I'm Francisco Ortega Culaciati. I'm a geophysicist from the University of Chile. And I do research on seismic cycle. I use GNSS. I process GNSS data. But my passion is for inverse method, as you probably saw in my presentation.
My name is Bianca Glass, and I organized this meeting for you. I'm from the University of Tarapacá.
Good afternoon, everyone. I'm Patricio Catalan. I'm a professor at Universidad Santa Maria in Valparaiso and also a researcher at CN. I've been working on tsunami science and hydrodynamics for 15 years, say. And I'm interested in everything about tsunamis, from the pure hydrodynamics to mitigation and early warning systems. Thank you.
Good afternoon. My name is Emilio Cal. I'm emeritus professor at Northwestern University in Los Estados Unidos. I'm essentially a seismologist who was converted to to working on tsunamis early in my career. And this is my second trip to Arica and my nth trip to Chile. So I'm very grateful to have been invited. Thank you.
My name is Sergio Barrientos. I am associated with the National Seismological Center of the University of Chile. Unlike Emil, I think I still am a seismologist.
Hello, my name is Ricardo Norambuena from the University of Concepcion, and I am helping Bernardo and especially helping Bianca here in the organization of this nice meeting. Thank you.
Hi, Marcelo Lagos from Pontificia Universidad Católica de Chile. Hi, professor. For 25 years, I work with tsunami risk and scientific communication to communities.
Hi everyone, my name is Juan Gonzalez. I'm a researcher in Sweden. This is a center of related to make some hazard assessment related with tsunamis, earthquake, and other things. My main focus is the numerical modeling, and well, the last time I liked the cascading hazards, and I'm working in this. Thank you.
Oh, good afternoon. My name is Gabriel Easton. I'm a professor at the University of Chile. I'm a geologist. I'm working on paleoseismology and also on paleotsunami research together with Diego and James and other colleagues. Thank you. And thank you for the invitation again.
Thank you very much. We have one more person here.
Good afternoon. I am Jorge de Lama, director of Indesi to Tacna. Thank you.
Thank you all and welcome. Okay, so I'm going to...
Diego,
yes.
we have a few colleagues online.
Oh, yes,
well.
That's right. Can we get the screen? Yeah. I'll be brief. Yes, maybe Sasha, do you want to go ahead and introduce yourself?
I'm Alexander Rabinovich, but all friends know me as Sasha. And all my life long, I'm working on tsunamis, beginning from the university. But at the same time, I'm big fan of tides. And actually my PhD was on tides and on data processing. Just now I am at the Institute of Ocean Sciences in Sydney, British Columbia, but my permanent place of job is the Institute, Sheshov Institute of Oceanology in Russia. At the same time, I'm the editor-in-chief of Pure and Applied Geophysics on atmospheric and ocean sciences, and everybody is very welcome to submit their papers to our journal. We will be happy. And especially we like some papers related to some interaction between different geophysical disciplines.
Okay, thank you very much.
Gracias.
And do you want to go ahead?
No.
Sure. Hi everybody.
Yeah.
I'm Anne Soquet. I'm a professor at Université Grenoble-Alpes, and I'm affiliated with ISTER Laboratory, so in France. And I'm a geodesist. I'm mostly interested in subduction zones. I've been working in several places, in Indonesia, in Japan, but I've been working in Chile since 2007, and since 2012 I've been working also in South Peru. So hopefully we'll be able to do this joint model linking South Peru and North Chile.
Thank you. And Mohammed, do you want to go ahead?
Hi, everybody. I'm Mohamed Shlier from Easter Laboratory. I work with Anne with a very similar profile, interested in geodesy and seismic hazard in subduction zone mostly. I regret to not be with you when I see you all with your clothes. It's so hot here in France. But thank you very much for organizing this very interesting meeting, and we will present tomorrow some results of our work in this region. Thank you.
Thank you, Mohammed. Okay, we had Slava Gusiakov online, but I think we lost him. Is there? Oh, there you are. Yeah. You want to introduce yourself?
I am here.
Yeah.
Thanks. My name is Slava Gusikov. I am almost 50 years in tsunami business. Still the head of tsunami laboratory in Novosibirsk. I have been in Chile 5 or 6 times, and including Arica, in Peru also. Subject is very interesting for me, and I appreciate very much of this kind of this workshop. This very interesting subject, and especially I appreciate the last presentations, and looking forward for paper. Please let me know when it will be published.
Okay, thank you, Slava. Okay, I think that's all. We don't have anybody else online, right? Okay, so we're almost done with the time. So if you just allow me 5. Bernardo?
We have Eric Mas, Eric Ortega, Paul Quispe. I think.
Are you online? Eric Ortega?
Hola, ¿qué tal?
Hi. Okay, go ahead and introduce yourself. Sorry, we couldn't see you on the screen here, so I didn't know you were
¿qué tal?
online.
Gracias. Good afternoon with everything. I am Eric Ortega, geographic engineer. I work at the National Tsunami Warning Center, Peru. My expectations is this meeting is to have the contribution of all you. Thank you very much for the invitation.
Okay, thank you, Eric. Anybody else online that hasn't had a chance to introduce him or herself? Eric Mas, maybe? From Japan?
It's very late in Japan.
Okay.
Yeah. I think that we are done.
Okay, all right. Well, thank you very much for the introduction, and I'm just going to take 5 minutes just to tell you a little story, and then a couple of slides only. I said earlier that I was going to be a little bit more specific about the outcomes and objectives that we try to get out of these meetings, and the motivation. And so, let me start with the story. This is the nth time that I come to Chile, but I came after the 2010 event invited by Dr. Lagos here to help with the field survey there. And I remember that on that trip, we went to Constitucion, and we were doing the survey of a small island at the mouth of the river there. What is it? What was that? Orrego Island, yeah. And it had been devastated by the tsunami. There was a large community of people that had been celebrating, camping and celebrating the night of the tsunami. And there was complete destruction, devastation. All that was left was the sand deposits, the erosion, and the belongings of the people that had been celebrating there. And they couldn't evacuate because there are no bridges, and there were just a limited number of boats. So we got to the island. We split up into different, to cover different areas. So we were by ourselves. It was all very quiet, very kind of eerie silence in the island. After, in your imagination, you try to replay what happened there 24, 48 hours before. And I was working by myself in one area, and I ran into someone. I was a little bit surprised when I saw someone coming and walking my way. And I didn't know who that person was, but it was some local. And he came up and asked me what I was doing there. And then I told him that we were scientists and that we were conducting a field survey of trying to collect data of what had happened. And then I answered back who he was and what he was doing there. And he told me that he was looking for his 5-year-old. And that response to this day is still with me. Still gives me, you know, emotional shock when I think of it. And then when I think on all of us that work in tsunamis and why we have these meetings and why we publish the papers and why we do the research and the field work that we do, it's really the motivation that I think it's driving these meetings. Like I think Carlos said, we're concerned about this because it's about human lives that we have to save. So there is the research on one side, and there's the professional careers and the publication of papers, and there's all this. But there's the other side that it's even more important than that. So it's good to keep it in mind. And another thing that I admire of Dr. Lagos during that trip was his talent to tell stories. So I said, I'm going to try to mimic him and do the same thing. So anyways, so that motivation should be present for all of us. But also what we try to get accomplished with these meetings, and this is one of many meetings, of a series of meetings that are taking place all around the Pacific and the Atlantic and the Caribbean, and they're all sponsored by IOC, by the Intergovernmental Oceanographic Commission, and they're trying to accomplish the same thing, the identification of tsunami sources. And that is the main objective, but they also serve as a forum for other objectives. And then together with tsunami sources, there's many tsunami-related topics that surface during the discussions that, and maybe these meetings, sometimes we have more time, other times we're a little bit more constrained and we don't have that much time to touch on other subjects, but they could serve as not only, to identify the sources, the tsunami sources, and for regions like, for instance, northern Chile, southern Peru, we want to make sure that if we conduct tsunami modeling, there's some consistency on the work that's being done across borders, because these events don't know about that there's a border between Chile and Peru. And so you don't want to be telling the Peruvian population that something's going to happen and the Chilean population that something different is going to happen during an event. So there's got to be consistency in the warnings and in the forecast. So that's one of the reasons. And you want this standardization of sources to be to have a consensus in terms of the scientists that are, especially the regional, the local scientists that are most familiar with the tectonics and the local faults, to be the ones determining or using their best guess as to what those sources might be. So, as we mentioned, we have some of the agencies that are responsible for issuing warnings and evacuations, where they're also present in the room. So it's an opportunity for them to assess the capabilities and how things are done differently in Peru that they may be in Chile. Same as the forecasting capabilities. What are the techniques that are used? What are the instruments that are used? What are the networks of instruments that are available in the area? Which ones of those instruments are research networks and which ones may be used in real-time forecasting, for instance, because they have real-time reporting available to them. So it's an open discussion on that, on all those topics. And then, the different seismic sources, even though primarily this workshop is focused on seismic sources, we do not want to ignore that there may be other sources of tsunamis, like volcanoes or meteor tsunamis or landslides. So, but primarily, the objective is the identification of tsunami sources that can affect the coastal areas of these areas. So, and the outcome, what we need to produce, not at the end of this workshop, but we have to have sort of an idea of how to produce the product. Is a report. Each one of these workshops that IOC, UNESCO, IOC are celebrating, end up with the publication of a report where the findings of the experts are reflected in a way that can be used by the community but to a level of specification that can be used also by tsunami modelers to run their models and produce inundation maps for these sources of tsunamis that the experts have identified. And so that is one of the most important objectives, because once you had that definition of sources, and then that information can be used by tsunami modelers to produce inundation maps, and by emergency managers to produce evacuation maps, and by a large number of other communities that are affected by the tsunami. So we realize also, well, I just wanted to emphasize that this is the last of a series, and these are only a few of the workshops that have been taking place previously, exactly in the same series with the same objectives, and there's reports already published by each one of these. So one was in 2016 for the Dominican Republic, the areas around the Dominican Republic. In 2018, we had the Tonga Kermadec that took place in New Zealand. There's another one for the tsunamis in the Lesser Antilles in 2019. The last one I participated in was just immediately north of us for the Colombia-Ecuador subduction zone region. And so, and this is now the one we have now in August of 2023. So, and they will continue as we cover different parts of the Pacific and Caribbean and other areas where this may be an issue. Okay, and this is an example of a couple of the reports that came out of those meetings. So one thing we will do before the end of the meeting is I will build a sort of a straw man of what the report should say, and it's really not very taxing on any one of us. There's many experts here, and as long as each one of us contribute a little bit to the report, like 1 page or something like that, it ends up, we will end up with a pretty detailed and comprehensive report that is very useful to tsunami modelers. So that would be an example of a couple of the previous reports. And finally, I come from a tsunami modeling background in engineering, but not a seismologist, and so I'm not an expert on the sources and the talk that's going to take place here. The conversation is going to take place here these days, but I come from tsunami modeling. And so we're now at a point where evacuation maps are almost a must-have in the communities that are threatened by the tsunamis. So we have to realize that to have a tsunami evacuation map, we need to have conduct numerical simulations, numerical modeling, and end up with an inundation map. Here's, for instance, just a sample evacuation map of an area of Washington State where I used to live, Tacoma, and that it was generated after tsunami modelers generating this hazard map of the tsunami inundation. So we got to have the numerical modeling. And so many times as a tsunami modeler, you're confronted with the fact that you have to generate this type of maps for communities for which, but no one tells you what source you should be using for that community. And so, you know, and someone mentioned it earlier today, you try to reach out to the experts, but this is an elusive answer when you ask them what's the worst, because there's a lot of uncertainty as to what might happen in any part of the world, and that's understandable, and nobody really knows have much certainty on what could happen. So, but the problem is that if the seismic experts do not answer that question, then what happens is that the tsunami modeler, which is much less prepared to answer that question than the seismic experts, has to find a solution to the answer, because he has to tell the model what it needs to do with the specificity of fault parameters. And so we understand that there's a lot of uncertainty in what we are trying to do here, but we'll go with the best available knowledge that we have, with the understanding that we may be wrong, but that's why we want to work with the best experts in terms of trying to get the best possible solutions as of today. Maybe 5-10 years from now, there's a new finding that realizes that what we've been saying is an underestimate of what could happen, and we'll go and review it, but we'll go with what's the state of the science at this point. And so this is uncomfortable for many scientists. I realize that because nobody has a crystal ball on what's going to happen. I'm going to skip all this part because I just wanted to show you how the tsunami modelers used to approach that problem in the past. Let me stop here real quick. Okay, so this is an example of how we came up with those estimates in New Zealand for the Tonga-Kermadec Trench, sort of. And so what the experts did at the time was to analyze rupture segments along the Tonga-Kermadec Trench that they think where they think the rupture may stop. And so they would put a limit on the size of the earthquake that you can have in that particular region. And so and then they realized that there could be combination of those segments, that the rupture may not necessarily have to stop in a particular boundary and may cross boundaries, and they don't know how hard those boundaries are. So they estimated along the trench that there could be different segments rupturing, but there could also be combinations of those segments, and that would result into earthquakes of different magnitude based on different scaling relationships that they used. And then based on the length of the rupture, with the scaling relationships, they guesstimated the size of the event that could, in terms of the magnitude of the earthquake. And then once we had that, we need actually, the tsunami modeler needs something more specific than that. We need even more than the magnitude and the location and the length or width of the rupture, but we need the entire fault plane parameter definition. So this is, of course, you go into a level of specificity that is very hard to achieve. So for this, we used parameters that, for instance, in the NOAA Center for Tsunami Research, it has a database of unit sources, sort of like most of it is based on SLAB2 model of tectonic geometry. And so we derive, when experts don't want to go to that level of specificity, we try to derive those fault parameters from the database, the NOAA database. That's one I'm familiar with. That's what we did in New Zealand, but it could come from any other database if it's available. So, so we can get to the point where we can define the length, the magnitude, and the rest we could derive the fault parameters from this database or any other database. And then in terms of assigning probabilities, we do it in a very quantitative way, or qualitative, I should say, qualitative way. We define that the longer ruptures are low probability, the medium ruptures, medium probability, and the smaller ruptures, which are probably more frequent, have high probability, but we don't assign values to that probability. So so fortunately, we don't go to that level of specificity. So anyways, I'm going to leave it there. We have a couple of tools that can help us in the discussion, but I will introduce them when we start the discussions in the breakup groups, and I'll skip that because I think everybody wants to run to lunch. So we're over my 15 minutes, but we made up for some of the last time. So we'll continue after our lunch. Thank you.
estuviera hablando. Ahí. Que salga el banner, ¿eh? ¿Sale el banner? Ahí. Y ahí. Ya.
Yes, yeah, vaguely. And it was, they said that there was an American number.
Yes. And that woman in B&B.
Yeah, I remember that one.
Muy bien, muchas gracias. You send this to Costas in Spanish, we miss you.
Contact him in case he's in LA.
Me vamos a colocar así. No te pongas así. Ya, Juan, usted el medio. Yo soy muy desordenado, usted es el caballero formal. Excelente.